Hello everyone, and welcome to the Waveshare ESP32 Getting Started tutorial. In the previous lesson, we learned how to create and run an ESP-IDF project. However, in real-world development, bugs and unexpected behavior are inevitable. In this lesson, we'll learn an essential skill: program debugging. We'll focus on how to use the ESP32S3's JTAG interface for debugging right inside VS Code, so you can quickly find and fix issues in your code. In embedded development, there are a few different ways to debug. The most basic method is serial print debugging, by using printf or ESP-IDF's logging system. You can output variable values and program status to the serial terminal. It's easy to implement and very practical when you don't have professional tools. But print debugging has its downsides. You have to modify your source code to add print statements. Every debug cycle means recompiling and reflashing. You only see the final output, not what's happening while the code runs. And for tricky logic bugs, it's just not very efficient. A more professional and powerful method is hardware debugging. The ESP32 series supports hardware-level debugging via the JTAG interface. JTAG stands for Joint Test Action Group. It's an international standard test protocol that defines the communication interface between the chip and external debug hardware. With JTAG debugging, we can set breakpoints, step through code, inspect memory and variables, all without modifying a single line of source code. In the ESP-IDF development environment, this all happens through a chain of tools working together. First, you start debugging from VS Code, which invokes the GDB debugger client, a special version called esp-gdb, optimized for espressif chips. The GDB client then talks to the OpenOCD server. OpenOCD, or Open on Chip Debugger, is an open-source tool that bridges the debugger and the hardware. We use the OpenOCD ESP32 branch from espressif, which adds support for newer ESP chips more quickly. Finally, OpenOCD connects to the ESP chip through the JTAG interface. For the ESP32S3, that's built right in. No external JTAG adapter needed. You just use the USB-Serial-JTAG Peripheral. With this toolchain, we can easily control and observe the program running on the chip from within VS Code. Newer chips like the ESP32S3, ESP32C3, and ESP32P4 include a built-in USB-Serial-JTAG Peripheral. It contains both a USB to serial converter and a USB to JTAG converter. A single USB cable to your PC provides firmware download, debugging, and system log printing. For development boards that do not have USB-JTAG capability, you'll need an external JTAG debugger. However, that is beyond the scope of this lesson. After connecting the development board to the computer via a USB cable, open Device Manager. You'll typically see two devices, one under ports listed as USB Serial Device, used for downloading code and viewing logs, and the other under Universal Serial Bus Devices, listed as USB-JTAG/Serial Debug Unit, used for JTAG debugging. Before debugging, we need to ensure the JTAG driver is properly installed. Let's check. Locate the USB-JTAG/Serial Debug Unit under Universal Serial Bus Devices. Right-click and select Properties. Then go to the Driver tab. If the driver provider shows libwdi and the digital signature is issued by Espressif Systems Company Limited, then the driver is correctly installed and no additional action is required. If the driver is not correctly installed, we need to install it manually. Run the ESP-IDF Installation Manager again with administrator privileges. Click Open Dashboard on the main interface, then click Install Drivers. In the driver security prompt that appears, click Install to install all the drivers. After installation, a driver installation successful notification will appear at the top of the EIM window. After installation, reopen Device Manager. Check the properties of the USB-JTAG/Serial Debug Unit again, and confirm the driver information in the Driver tab has been changed. If the driver information still has not updated, you can click Update Driver to refresh the status. If you see libwdi as the provider and the digital signature as espressif, the installation was successful. With the driver confirmed, let's move to the hands-on part. First, create a new ESP-IDF project. Then, copy the example code from the tutorial document into main.c. This code is straightforward. @main calls summation. to compute the sum from 1 to 6 and prints the result over serial. Before debugging, let's flash and run it normally to ensure the program works. Confirm that the flash method and serial port are correct, then click the Build, Flash, and Monitor button on the toolbar. After flashing completes, you can see the correct result, 21. The program is running normally. Now we'll configure and start OpenOCD. Before starting debugging, we need to configure and launch the OpenOCD server. First, we need to tell VS Code which debug method to use. Press Ctrl-Shift-P to open the command palette, then search for and select OpenOCD board configuration. From the list, choose ESP32S3 chip via built-in USB-JTAG. Second, start the OpenOCD server. Open the command palette again and run esp-IDF OpenOCD Manager. Then click Start OpenOCD. You can also click the OpenOCD icon in the bottom status bar directly to start it. The terminal will begin printing logs. When you see the message, listening on port 3333 for GDB connections, it means the OpenOCD server is ready and waiting for a GDB client to connect, and the status bar now shows OpenOCD server running. The OpenOCD server is ready, so now we can start debugging. First, set a breakpoint on line 8 of the code, where sum plus equals I is located. Simply click in the blank space to the left of the line number. A red dot will appear next to the line number, indicating that the breakpoint has been set successfully. Now press the F5 key to launch the debug session. You will see that the VS Code interface changes. The program pauses by default at the first line of the app main function. Panels for variables, watch, call stack, and others appear on the left, and a debug toolbar appears above the code. These are the main tools you will use for debugging. Let's first get familiar with the most commonly used operations. Click the Continue button on the toolbar, or press F5 again. The program will continue running until it hits the breakpoint we set. As you can see, the program is now paused at line 8. The highlighted yellow line indicates that this line is about to run, but hasn't yet. So in the variables window on the left, the value of sum is still 0, and the value of I is 1. Next, let's try step over debugging, which is the F10 shortcut. Each time you press it, the program executes one line of code. Press it a few times and check the variable window on the left. You can see that the values of I and sum change as the loop runs. If you want to pause under specific conditions, you can use a conditional breakpoint. Right-click the breakpoint, select Edit Breakpoint, and enter a condition. For example, I == 6. Now click Continue, and the program will keep running until the moment I = 6, when it will pause again. This feature is very useful when debugging complex loops. Step over, F10, executes a function call in one go without stepping into it. If you want to step into a function to see its internal execution details, you need to use step into, F11. For example, if you use step into on the printf line, it will try to enter the source code of the printf function. As you can see, VS Code prompts that the source file cannot be found. This is because printf comes from a precompiled C standard library, and its source code is not available locally. If you continue pressing step into at this point, you will keep stepping into related code, none of which we care about. In this situation, click Step Out, Shift plus F11 to return to the place where it was called. Finally, when debugging is complete, click the Disconnect button to end the debug session. Well, that's it for this lesson. Let's quickly recap. We learned the principles of JTAG debugging and its toolchain. We configured and started the OpenOCD server for the ESP32S3. We practiced setting breakpoints, starting a debug session, and using core operations like continue, step over, step into, and conditional breakpoints. In the next lesson, we'll dive into another core part of ESP-IDF, FreeRTOS. We'll learn the basics of multitasking programming. If you found this video helpful, please like and subscribe to support us. Thank you for watching, and see you in the next lesson.